So, hi everyone. I guess I got the cue that I think we are now live. I hope you're doing good. Got yourself a nice cup of freshly brewed coffee. Got mine right here. So cheers to everyone. We're in the same position, confinement situation as us. Special mention also to all you parents who are trying to balance taking care of the kids and working. So I'm myself a father of a 4-year-old girl and a 2-year-old boy. So just as we're starting, we're getting people to wait to log in to get accustomed. Just take the time to introduce myself and my role here at Eddyfi. So my name is David Veilleux. I'm a mechanical engineer by training, and I'm part of the tubing team at Eddyfi. My role in the team is to support the clients. So whenever they need to buy a probe, they need some training or product support, I'm there. I also work on TuPro, the reporting software, and I help with the product development. So before we get going, I guess that the way if you'd like to interact with me, the only way to do so is by using the chat feature. So you need a Google account, and to log in to your account. Once it's done, you should have access to the chat feature at the bottom right of your window, and then. Since there's a 30-second gap between the moment I speak to the moment you get the feed on your computer, I will only insert the questions at the very end. So maybe I can go look on the page if I get any feed. So there are quite a few people that I see. 16 watching, so I think we're good to go keep on doing with the presentation. I will switch to a presentation mode here. So for this little presentation, the team and I thought it'd be interesting to talk about the chillers. So what are they? Where are they used? And how they can be inspected so they keep running in critical times. Invented more than a century ago, air conditioning is an essential equipment in our modern day lives. With global population constantly growing and people living more and more in city centers, we can easily understand that the demand for comfort will continue to rise. So according to Business Insights, the global commercial air conditioning market value was 14 million units in 2018 and is projected to reach 19.4 million units by 2026. Exhibiting a compound annual growth rate of 4.3% during that forecast period. Also, almost 50% of that demand comes from the industrial and commercial sector. Air conditioning is part of the larger heating, ventilation, and air conditioning systems known as the HVAC that are in place in large buildings. As we can see here, it includes all the ducts and the equipment to control the heating, the cooling, humidity, and air quality of the buildings. And according to Wikipedia, the air conditioning role in general is to remove the heat and moisture from the interior of an occupied building or facility and improve the comfort of its occupants. So when we think of AC, we think about keeping people cool during summertime. So yes, it's important. We all appreciate it, but imagine how critical it can be in a building like an hospital. Also, keeping the air temperature cool can be critical to some processes, like a plastic transformation, equipment like servers in a data center, or in a factory like food processing. So. Air conditioning can be done in various ways. There are a multitude of equipment available, but today we'll focus on one of the most popular systems, which is called a water-cooled chiller, which looks a little bit like this. So that's a basic chiller. To be efficient, water-cooled chillers need to be used in larger building and processes. So thanks to engineeringmindset.com, we can compare the size of a chiller compared to building sizes. So if we the chillers are used in medium-sized buildings with cooling loads of 200 to 400 tons of refrigeration, and larger sized buildings with cooling loads over 400 tons. When we look at the HVAC system for a building, the chiller is generally located in the basement. The chilled water leaves the chiller on the right side. So I don't know if my mouse is, you can see my mouse, but the circuit on the right is going to leave with cool water. The chiller is going to go all the way to all the floors of the building. And then cool the air, and also attracts or remove the excess heat from the air and bring it back down to the chiller. Then this heat is transferred from one compartment to the other, and this one is related to an equipment that is on top of the building, the cooling tower. And on this cooling tower, this is where the extra heat is going to be rejected from the circuit. So, and the closing in on the chiller itself. So the main part of this system is going to be the chiller in the middle in the basement. So we got the evaporator on top and the condenser on top, and these two are none other than shell and tube heat exchanger. So at Eddyfi, we know a thing or two about inspecting this equipment. Similar to what you would see in oil and gas, petrochem or BOP, these heat exchanger need regular maintenance. They need to be opened, cleaned, inspected. This picture shows the tube sheet of the evaporator at the top and the condenser at the bottom. That the cover has been removed. They have been cleaned and they are now ready to be inspected from a technician, like you can see on the right. Generally, these bundles are smaller and vary from 250 tubes to about 1,000 tubes. For any given cooling load in a building, and then it's better for maintaining efficiency and to accommodate the cooling loads that vary between the seasons. So thinking about the spring and fall, you don't need the full cooling capacity instead of in North America, let's say for July and August. So instead of having one big chiller, it is more efficient to use multiple smaller chillers to accommodate for those variations. So again, thanks to Engineering Mindsets for the good representation. So you can see here that we got first the big one. I would say that maybe the building would require 2,200 tons of refrigeration, but instead of having this big unit, the engineers doing the building, they're gonna decide whether they're gonna split it in 2 or even 3 equipment. Also, finally, the other thing is that because these equipment are critical to some operations, there is often what is called system redundancy, meaning that if you need 2 chillers for your cooling load, well, you're gonna add a third one just in case. If one fails, then you got a backup one, and you can maintain your operations, whether it's cooling your data servers, having your facility continue making food if you need it, etc. So this also makes the inspection process much simplified, as they can be inspected all year long instead of waiting just the winter when they're off. So looking at it from an NDT perspective, these are simply shell and tube heat exchangers, but they're in a class of their own a little bit. They're a little bit different than the other ones. So what makes them unique? Well, it's the tubes. I will switch here. I will show you a little bit. So the tubes are a little bit different. In basic heat exchanger, the tubes are straight and made of ferrous or non-ferrous material. for different diameter and wall thicknesses, and they vary a lot. I will switch now here. It's gonna have a better view myself. So for chiller, this is, I have an example here. That's our calibration standard for the test. First thing that it's unique a little bit about these guys, it's the type of material is limited to copper and copper nickel alloys. So you can see here, as well as the picture on the top. Second thing is that they are mechanically enhanced. What that means is that once the tubes, while they're made, they're gonna have small grooves. It's not fins, it's just really small grooves that are carved inside the material. You see on the picture there at the top, it can be internal or also external. So here you see on my camera, I don't know if you can get a good view of it, but you see that that is a clean section, straight without anything, and here are all the grooves that are on top of the tube. You can have tubes who have both, so they have internal and external, or just one or the other. These are the carves help for to enhance the heat transfer. To fix those tubes in the heat exchanger, the third thing that makes them special is the what we call the land area. So that's a region in the tube. It is there. I hope you can see it properly. But it's a region here without any fins. So you got a fins, and now it's a thicker section where you're gonna want to put the support plate and fix it to it. And fourth difference is that generally these tubes are very thin, thinner than what we see in normal shell and tube heat exchangers. So between 22 thousandths of an inch to 28 thousandths of an inch, and in metric, so it gives about 0.56 millimeter to 0.71 millimeter. And the tubes are whether 3/4 of an inch OD or 1 inch of an OD. So these are basically the ODs that we see, meaning it's 25 millimeter at the bigger and 19.05 millimeter for the smaller ones. Now that you know a little bit more about the chillers, you know where they are used in the HVAC systems to cool the air, not just in buildings, but for some industries like petrochemical, food processing, as well as equipment in data center. You know that there are shell and tube exchangers, that the tubes are a little bit different with the fins and copper. So yes, I hope that you're telling yourself, wow, these chillers are really important, and I better make sure they don't fail on me, as they can be really critical to my operation. So the best way to prevent that from failure, well, not other than maintenance and inspection. So with times, some defects can be found inside the tubes. The most commonly found ones are ID pitting, so small holes, small pits that you can find inside the tubes. OD frittings at the land area. So here, I don't know if it'd be possible to see here, but we do have an example of OD fritting. So it's going to be a loss of material that you will be able to see at the land area coming from the support plate that is vibrating on the in this region and removing some material. There's going to be ID cracks also that can be located, and ID corrosion. But keep in mind that there are a lot of mechanical or physical thing that can happen and can induce damages like galvanic corrosion, impingement, deposits and waterline attacks, crevices, corrosion, ant nest corrosion, fatigue, stress cracking, and a lot of things take their toll on the tubes. So it's clear that these the tubes will deteriorate with time, and then they will potentially fail. And even if the tubes they just start having a little bit of corrosion and pitting, their efficiency will lower, and you will see it in the efficiency of your air conditioning. So cleaning them will definitely help maintain the asset, but it will not give the owner the current state of the equipment. So to do so, and this is where Eddyfi comes in, the best way is to use a special ECT probe designed for these tubes. So I have one right here that I can show you. So that's for you familiar or not with this. So that's going to be the ECT AC probe with a detachable head. If you're less familiar with ECT technology, I suggest you click on the link below. I guess if you click on show more in the description, I did put a few links that for you to access. Visit them. We have a lot of material content for you to learn more about ECT. This probe is entered in the tubes, as simple as that. So the technician will scan all the tubes in the heat exchanger. And what we will get out of this, it's the percentage loss of material that we call the wall loss. Just to give you an idea of the defects that we're normally looking for. So for a conventional building, these tubes are judged to have reached their end of life if they have a 40% wall loss that is detected. For essential buildings, such as hospital and data center, the criteria is lowered to 30%, which means that for a tube of wall thickness of 0.6 millimeter, a wall loss of only 0.18 millimeter will mark this tube as not good anymore. So what they do is, if you see 30% wall loss, then you will not put water in this tube. We do what the action is called is plugging the tube. So we put a mechanical plug at the beginning, so it cannot be used. So therefore, so in meaning that only a 0.18 millimeter of wall loss will make this tube not good anymore. Therefore, the inspection technique must be precise. Same with OD fretting, 30 to 40% wall loss will deem the tube unusable. And if we ever see a crack, then it's going to be the same. It's going to be plugged. What I'm saying is that once we acquire we get the probe inside, this is going to be connected to the ready AC, like acquisition equipment like this one. The probe is going to be connected here through the ports. This is a portable equipment, and on top of it, this you will see. I have it. Click here. Okay, that's better. This is what the technician will see. It seems this is going to be for part 2. I will exchange you maybe in further another opportunity how this is working. But this equipment can be brought on site. As remember, we were telling you that this is in the basement in these conditions. So it's almost very small. So it's very handy to have a really small equipment. And this one is battery operated. And with touchscreen, you can do all your inspection, save the data, create your report, and do it very quickly. So I think it wraps up a little bit what I wanted to present to you. I hope you learned at least one thing from the presentation. The water-cooled chillers are really common. They're shell and tube heat exchanger. They also need to be inspected. So whatever business you are in, whether it's a casino, hospital, data center, so this is very important. This is where Eddyfi, we have the probe, especially designed for this application. As I mentioned, with the land area, material, and the fins. Also, we got the acquisition equipment, portable equipment that the technicians can bring back down to the basement. And finally, we have a reporting software that I mentioned a little bit in my introduction to Pro, where that helps you represent the results easily and consistently also to the customers. I will not, for today, I prefer to leave the Ready AC for another presentation. I think we've covered the less. I guess we'll probably do another one. Just if you're interested, if you want to see it scanning the tube, just let me know in the comments. And we'll plan a second coffee break in the meanwhile. So if you have any questions, I will. This is a good time to ask them. I will go open the browser, see if I got something here. So what I see here, okay, for C, I guess how can I decide? So we got something here is that how we can decide which probe diameter to use for the inspection. So as I mentioned, the probe needs to go inside the tube. It needs to vary from like a 1 inch to 1/4 inch, etc. So normally what we aim to is to have the probe to have an 88% fill factor. But to make sure you're good, we suggest you go on the website. There's the tubing probe creator that is accessible. Enter the material, the dimensions, wall thickness, and then the OD. And then we suggest one diameter that it seems to be optimal. If you have any questions, however, don't hesitate to contact us. This is part of my job to help the customers in those situations. So if you have any doubts with the fins, the grooves, don't be afraid to reach out to us. We'll help you with it. And sometimes what people really do is that because it varies and it's hard for the inspection company to really know the diameter before they get on site, we sell like a package of 5 most commonly used probe heads. So as I mentioned, the head is detachable. So we have 5 common diameters that the technician on site can switch easily and be ready to do the inspection. So that's good. Are there any chiller manufacturer using this? For the moment, yes, we have some of the manufacturer using them. It really depends on their needs, but we see very good potential for these manufacturer because this is simple, it's easy to use, and whether they want to do it at the factory before the chiller goes out or offer it in the service package or whatever they want to manage it. This is a good opportunity, and it's really easy to use. The software interface can be learned fairly quickly, and we have a lot of tools. I wish I can, if you're interested, we're gonna go see in the next video how we can really actually see the defects, measure them, and compare them. So this is going to be important, but it is definitely something that is user-friendly, that can be used from a manufacturer using chiller manufacturer. Got one over here. So there is one, you said that 30% wall loss of the specific tube is often a threshold to retire it for hospital data chiller. Do you have numbers? Must be okay for chiller to still operate. So what it means is that you're right. Thank you for the question. Yes, in the case there is one tube with 30% wall loss, then it is going to be deemed unusable. However, the exchanger is still usable, and there's going to be a threshold. So if you have 100 tubes in your heat exchanger, sometimes it will depend from manufacturer one to the other, or the facility, the company that is using the runner. But in tubing, like in refineries, the most common number we heard, and this is up to them to decide, it's 10% plug tube ratio, meaning that for 100 tube heat exchanger, if you plug 10 tubes out of them, the efficiency of the equipment is going to be too low, and they prefer to replace the tube bundle, extract it, change it on completely, and then remove it. So it's not that many tubes that can be plugged before this exchanger is deemed unusable. So it's very important that is, if you know. And also from that inspection knowledge that we learn from our clients is sometimes the purpose of the inspection is not really to see if there are any tubes to be plugged right now. It's to know if in 2-3 years I will need to plug tubes, and in that case, will I still be able to use my equipment, or the corrosion rate is too strong that I need to plan in 2 years to buy a new heat exchanger or the tube sheet. So it's very important that it's not that many tubes. So at about, I would say, however, if you have more info about it, I'll be interested to hear about it. But what we heard from refineries, it's around 10%, but it really varies from the owners. So I guess I don't have any other questions. What if? So I hope you guys appreciate it. Please leave a comment if you'd like, or email us if you want to reach me personally. Don't forget, there's my email address right here. If you have specific questions, I can answer them. And don't forget to subscribe to our YouTube channel. We're gonna have more coffee breaks like this coming up in the week. I think Wednesday we have another one from M2M, and then the other weeks we'll have my colleagues from Surface, and also lift system, etc. So join us. It's nice easy break from working at home, and you guys please stay safe, and we'll see you maybe in another coffee break.